What's going on, my ASVAB party people? Anderson here, your ASVAB coach. And in this video, got a treat for you. As always, we got a 2-hour recording on math knowledge where we're going to be going over how to find missing angles. So if you've ever looked at the difference between complementary and supplementary angles and it gets a little confusing, or looked at a problem where you have to find a missing angle inside of a shape, like a triangle or parallelogram or something like that, well, you're in good hands. So I'm going to show you exactly how to take care of problems like this, how to actually, understand the verbiage, when to apply it. That way you can have a nice smooth time whenever you see problems like this on the ASVAB. You're going to see a little bit of them, and at least 2 of them on the math knowledge test that you're taking. It's a good idea here. Go ahead and watch. And as always, if you're not in the program, well, you got to go ahead and learn more about it, all right? So look, my program covers everything you need to really destroy the AFQT. So if you're having trouble with math, blanking out on word problems, if you feel like you're not really apt to making a study schedule that works for you, staying focused, things like that, well, that's what I'm here for. I'm your mentor all the way through. I don't just provide the materials, but I offer you help whenever you need it. You can text me. Whenever you need a practice test, well, there's one there, and there are updates coming along the way. Video solutions for the math, so it's like I'm right there, step by step with you. There's so many different ways to learn and grow, and we do it all in one program here to help you get the best chance of getting the job you want. And so, with that said, go ahead, check out the link in the description of this video. There's a video that will show you exactly how it works, and you can always text me if you want to learn more about it. So, with that said, my ASVAB party people, let's go ahead and get to it. Let's watch this class, let's have some fun, and let's ace the ASVAB. Party people, let's get to it. Angles, basic notes. So again, today we're talking about finding missing angles. So long story short, classifying angles, finding missing angle that they give you on a diagram, looking at a shape and finding a missing angle in there. A lot of that's what we're going to be going through. But always, as always, we have got to get into the habit of getting those basics down, those fundamentals. That way we can kind of build on top of that. So what's an angle? Basically, this is the space between 2 lines. Like if you have 2 lines that are connected, the space between them, that's what's called an angle. And the number that we assign it is pretty much kind of saying how many spaces does it take up. If you have a 360-degree dial, how many of those spaces does it take up? So with that said, that is as basic as we're going to get. So now I'm going to go ahead and make myself smaller here. That way you guys can take these notes. So let's go ahead and get into more of the fundamentals here. So let me go ahead and say peace to y'all. All right. That's really big. So with that, we got 3 types of angles that you want to kind of categorize for yourselves. We have acute, less than 90 degrees. So anything from 0 to 90. So let me go ahead and kind of make this a little easier to see. And then let me use this. So trying to make that look like a dotted line. Cool. So basically any angle that is shorter or smaller than this, any line right there, as long as it's shorter than a right angle, you're good. And everybody remind me, how many degrees, what angle measure is a right angle again? Okay, sounds good. Yep, that is correct. A right angle is exactly 90 degrees. So let's go ahead and talk real quick. When it comes to right angles over here, how can you confirm, like absolutely 100% confirm on the ASVAB that you are looking at a right angle? What is something that they can give you that's not here right now that will give away that it's a 90-degree angle? Exactly, that tiny box where they intersect, exactly. So has anybody ever seen this right here? Has anybody ever seen that right there? That box added to an angle. That is the key. Like that is a guarantee that you're looking at a 90-degree angle. That's their tell. So that's a big sign. That is a huge sign right there. Let me just go ahead and highlight that. I'm just going to say indicates 90 degrees. That right there, that box tells the whole story. So did anybody here not like 100% have that down, but now they see that now and they're like, okay, I see that, we're good. Cool. Cool. Just trying to gauge where we're at there. Sounds good. And then lastly, right up here, we've got obtuse. So I'm going to zoom out in a moment. Just want to make that a little bigger for those who are using their phones. Remember, if you're using your phone, you can go ahead and turn that thing sideways if you want to. It'll make your life a little easier. So that's right, Dion. That's just for that box. That box right there, that means 90 degrees, you have a right angle. Yep. And then lastly, right here, we have obtuse. So basically, if you had any trouble kind of knowing like what numbers they're between, like, oh, 0 to 90, exactly 90, 90 to 180, just think about it as just knowing that it goes left and right of a right angle. So 90 degrees is that middle one. Always know 90 is the middle. One of them is more, one of them is less. All right. So, and remember that obtuse, it has to be less than 180 degrees. Bonus points for this one. Who knows what exactly 180 degrees is called? What is that called? Give me the full name. It's 2 words. Famata, thank you. It is a straight angle. Straight angle. Right there. That is a straight angle. That is correct. And then double bonus points. Who knows what it's called when it's beyond 300 or beyond 180, but less than 360? What's that called? They may not test you on this on the ASVAB, but I'm curious. Latifa, that is correct. That is a reflex angle. So more than 180, but less than 360, reflex angle. So I'll use purple right here. Reflex angle right there. So again, more than 180, but less than 360, that would be considered a reflex angle right there. So boom, go ahead and take a second to go ahead and copy that down. Remember, this is not something that you want to have to refer back to a lot. This is something that you want to commit to memory as soon as possible. So whether it's by using little flashcards or the flashcards on our website in the Math Bootcamp, if you're in the program, you want to make sure that you get the basic sets of fundamental facts down. Because when it comes to solving these problems, it's basically going to come down to this: your ability to recognize that you're looking at an obtuse angle, acute angle, straight angle, a triangle, a quadrilateral. Like, it's up to you to recognize exactly what you're looking at and how what you're looking for fits into that picture. But if you can't recognize what you're looking at, if you can't define it and say, oh yeah, that's right, these are all supposed to add up to 180, or that's right, complementary means they add up to blank. We're going to talk about that in a second. But it's up to your ability to recognize what you're looking at so you can see what you're looking for, again, fits into that picture. Yes or no? Does that make sense? I'm just really stressing the importance here of getting these basic, the fundamentals down. Like, we have to commit to this. So Krishan, long story short, just to keep it simple, man, what we're saying here is that we need to memorize these sets of facts so that way we can recognize them. So up next, my party people, let's talk about complementary angles. Everybody, complementary and supplementary. Has anybody ever gotten those confused? Yes or no? How often? How often? And even if we don't get them confused, sometimes you just stop yourself and go, but wait, how often does that happen? Yeah, I know. So again, this is why we have to do our job and commit the fundamentals to memory every single time. Every time you avoid doing that, again, you risk losing the information way faster than you should. And 2, you're not making like the learning exciting. You're kind of just thinking you're doing the bare minimum when you're not. And then that just leads to more frustration. So again, if you're going to do it right, get those fundamentals down. Again, complementary angles, basically, they add up to a right angle or 90 degrees. So let's talk real quick here, because this is where the reasoning with the ASVAB comes in. Everybody, if I knew that this right here, if those 2 angles, if I knew were complementary or it's supposed to add up to 90, everybody How would I find angle number 1 if I know what angle number 2 is? I have angle number 2, but I don't have angle 1. How can I get angle 1 using this information? Some of y'all say divide, some of y'all say subtract, some of y'all say add, some of y'all say divide 90, subtract 90, add, subtract. Okay, so this is where this reasoning with the ASVAB needs to come in. Everybody, let's think about it this way. Let's think about it this way. If we know that angle number 1 and angle number 2 have to add up to 90, if we know that they both have to add up to 90, if you think about it like an equation, shouldn't you just subtract that angle that you have from both sides? And so if you look at the directions here, like if I'm trying to look for angle 1, but I have angle 2, watch this. If I take away angle 2, right there, angle number 1, if I take away angle 2 from the 90 degrees, which is exactly what this looks like right here, watch this. If I take away angle 2, isn't that the same thing as doing this? Now I only have angle 1 left, right? And then I should have its value. I should know what it is if I take away angle 2 from the 90. So just want to make sure that you guys see this visually. Obviously, let's see it algebraically up here and then see it intuitively over there. So again, we got to get to the habit of seeing things, again, in more than one way. I'm going to try to do a good job here in this class for y'all. So, Krishan, not borrowing in a sense, but removing. So basically canceling in that sense, yeah. Now, supplementary angles, everybody. If I'm just complimenting you, I wouldn't say that's better than taking supplements or something like that, or drinking your protein shake every single day to make sure that you're fit. That's just one way to think about it. This is one thing I've had a really hard time kind of, I guess, expressing in terms of just making supplements sound better than complement. If anybody has a saying that they want to come up with, I'm more than happy to hear it. But long story short, supplements are better than complements. So supplements or supplementary angles, 180 degrees all the way through. The two angles add up to 180. Now with complementary angles, they add up to 90. So just remember those two types of angles, 90 and 180. Supplement is just the bigger one. Or think of supplement as super or something like that. Whatever you got to do. But again, two angles that add up to 180. Any questions? Yes or no before we move on? Because we got shapes up next, so you're going to have to make sure you take notes for this one. Go ahead and take the notes down. I'll give you guys about 15 seconds here. Yeah, so Dion, it depends on the question for sure. So if you have one of the angles in there, you can find the other one because you know it's supplementary. But again, you got to know it's supplementary. The problem typically tells you. But if you know that they're supplementary, take one of the angles away to find the other one. And yeah, we're going to go over examples, guys. Don't worry. I got y'all. No worries at all there. All right, so again, take a screenshot if you need to. Let's go and take a look at this next one here. So yes or no, did you know this? Like, did you know this as readily available information to you without having to think about it? The angles in a triangle, they add up to 180 degrees. If it has four sides, it's going to add up to 360 degrees. Yes or no, did you know that already at the top of your head? Welcome in, Jason. Triangles, yes, but not quadrilaterals. No worries. All quadrilaterals are just four-sided shapes. That's it. That's it. So it could be a square, it could be a rectangle, could be a parallelogram, trapezoid, a kite. It could be whatever. But yeah, quadrilateral just means four-sided shapes. So all we're doing right now is we're just going through the fundamentals. We're just writing down facts right now. That's all we're doing. We're just writing down facts. So here with triangles, just to go ahead and kind of exemplify this angle number 1, this angle number 2, and this angle number 3. For triangles, what we're saying is that angle 1 plus angle 2 plus angle 3 it equals 180. So when you take the measure of those three things, add them together, you're going to get 180. Now with quadrilaterals, with shapes that are four sides, basically, you're going to take a look at the four angles. Angle 2, angle 3, angle 4. All four of those add up to 180, or excuse me, 360. So all I got to do is just write this right here and we're good. Plus angle 2, plus angle 3, plus angle 4 right there equals 360 degrees for rectangles. And then if you have more sides, well, from 4, just keep adding 180. So for a pentagon, for 5 sides, that's 540. Then you got 720, then 1080, and then you keep going from there. Yeah, so just go ahead, add that up. There is a formula to this. So if you want to know, if you're curious about the formula, I haven't seen that you've needed it yet on the ASVAB. Has anybody ever been asked a question on the ASVAB asking about the total angle measure in like a 12-sided shape? Yeah, I didn't think so. I haven't seen anything like that. If you have been asked something like that, let me know. Seth, you have? Yeah, typically it's like finding one minus angle. Yeah, from everything I've studied, that's what I've seen. So yeah, so you may not need to know this at all, but the sum of the angles inside of any shape is equal to the number of sides minus 2. And you're going to multiply that by 180. So yeah, you can go and write that down if you want to, but you don't really need to know all that. So let's go ahead and start with some practice. Let's go ahead. Here we go. Now we're going to get to the practice. An acute angle is an angle that measures how many degrees? You have 20 seconds. Go. An acute angle is an angle that measures how many degrees? And y'all have the time that is left there. So you have 9 seconds here. 3, 2, and 1. Time. Go ahead, put those answers in. What do we have? An acute angle is an angle that measures how many degrees? How many degrees? Let's find out. I'm going to go and take this off of partial. An acute angle is an angle that measures how many degrees? So it's going to be A, exactly 90, B, less than 180 and greater than 90, less than 90, or greater than 180. Okay, so the answer here, acute angle. Think about acute as in, oh, look how small and cute. So we'll say less than 90. The answer is C. So if you want to think about it that way, again, if it's a small little acute angle, it's less than 90. Remember, use 90 as a reference. You can have one type that's less than 90, one type that is 90, and one type that's greater than 90. So there it is. Yes or no for those of us that picked the wrong answer. Are we good now? Are we good now? Make sure to take those notes there. We will be good. Right on. So let me go ahead and get this timer ready for a true 15 seconds there. All right, cool. So here's the next one, 3, 2, and 1. So I want to know in 20 seconds if you know the way to do this problem. I don't care if I don't want you to do the math. Can you figure out how to get there in 20 seconds? And if you can, great. If you can't, don't worry. If that's your first time, there's no shame. I'm just trying to see who here is starting to become proficient in this. Okay, so here's something that we're going to want to practice for. So again, me timing you this early on typically doesn't happen, right? This is a guided warm-up. I was just timing to see if anybody here knew exactly what to do. And some of y'all showed yourselves. So don't get discouraged there. Israel, if you want to go ahead and explain it, keep your hand up because I was going to actually call on somebody. So I'll call on you. But the idea here is that you want to go ahead here and be able to not look at the numbers at first. Anybody here, yes or no? How many people here sometimes freeze up just because of the numbers? Because they see something they don't recognize, a decimal, a fraction. How many times do you pause and hesitate for that only reason? Like you haven't actually figured out what to do with the numbers yet, but the fact that you're looking at something weird is like, okay. So again, that's a fair response. That's a natural response. but this is how we can kind of get over it. The one thing you need to understand is that you're worried about what you're focused on, and what you're focused on is something that you don't know. Obviously, that's going to give you anxiety. So let's focus on the rest of the problem, like the actual story that's being told and what you need to do. Because who's to say that you're not going to be multiplying that number by 1? Everybody, if you had a nasty number like 5.67259 written right there, and then it said, hey, oh, all you got to do is multiply it by 1. Is that problem actually hard? If all you're doing is multiplying by 1, no, that problem is not actually hard. So give yourself the chance to figure out what you're supposed to do with that number first before you have to freak out. That's all I'm saying. Before you let yourself have that freak out, understand what should be done first. Focus on that. So here, everybody, what are we looking for? Name it. We're looking for angle 3. Muhammad, that was lazy. So we're looking for angle 3. So Israel, I want you to go ahead, take over real quick. What's your opinion on what we should be doing to find angle 3?
All right. So in this case, it says if the angle 2 is 55 degrees, what is the measure of angle 3? So angle 3 and 2 make a straight line, which is 180. So we just have to subtract 55 with 180 to get 125. So that's the answer right there.
Boom, right there. So essentially, just to summarize what he said, because that was excellently stated, Israel said, hey, look, man, I recognize that this is a straight line. Everybody, yes or no, do we agree that from all the way in this green, from here all the way to here, that is a straight line? Can we all agree on that? Yes or no? All right, sounds good. Looks like everybody, Israel's on board. Now, I got another question for you. If that's a straight line, everybody, what is the name of this where you have 2 angles on a straight line? What are those kind of angles called again? When you have 2 angles that are hugging each other on the same line? Juan said it there. Supplementary. These are supplementary angles. That's a fact that you can draw from this. And so remember, everybody, how I talked about those fundamentals, how important that is. That's right here. That's where it comes into play. If you're saying, hey, I'm looking for angle 3, you got to do some detective work. What's going on around angle 3? It's on a straight line with angle 2, and we know angle 2. Supplementary angles, we can apply our knowledge and figure this out. So boom, we know that angle 2 and angle 3 added together is 180. We know that these are supplementary. Right there. They are supplementary. So everybody, is it fair to say, lastly here, that if we know that they're supplementary, meaning it adds up to 180, if I want to know what angle 3 is, I should take away angle 2. Like, does that look like it makes sense? If I take out angle 2, I can get angle 3. Cool. Glad we agree. And I forgot that I'm still timing. So let me go ahead and get myself back in play. But I really want us to, again, get used to this idea of math knowledge being just a quick, tiny puzzle, and then bam, procedure right after that. The puzzle being, can you recognize what you're looking at? That's it. That's really it. Can you recognize what you're looking at? So booyah, everybody, if we have 180, take away 55, what is that going to give us? That's going to give us 125 degrees. That's correct. That's 125 degrees. And so just a quick little detour to talk about our sponsors over at Mental Math World. So over here, everybody, if you want to do this in your head without much issue at all, one way to think about it is true or false, everybody. 55 is the same thing as saying 50 and 5. Right? Yeah. 55 is just the same thing as saying 50 and 5. So all I'm saying for a quick little mental math, a little like reprieve or a little appreciation here, subtract 50 first, then subtract 5. Same exact thing. Guess what? Makes it a lot easier. Everybody, what's 180 minus 50? 130. 130 minus that other 5, 125, and you're done. You can go ahead and avoid the whole Let me actually do it with a brighter colors just to show how annoying it is. And then from there, you do all the work. You know, you can kind of just get it done way faster. So with that, boom. Remember complementary angle, just to kind of guide you there for sure. Complementary angle is 90 degrees. Complementary angle is 90 degrees. That's complementary. Yeah, that's correct. Yep, Israel. Great job, man. Thank you again. Appreciate you, Israel. Sorry, whoops, right there. That is complementary. The timer's right in the way. But booyah, right there. We are good. So let's take a look at another example here. I'm not going to give you 20 seconds. I want you guys to take your time here. I'm going to come around and like kind of look at what some people's ideas are, and then I'll take answers in a bit. So don't plug your answer in. If you have an idea of what you need to do, type it into the chat box, and I kind of want to see what your suggestions are. Then in about a minute, we'll talk about it. So with that, there we go. Eviteo, there you go. You just got exactly what you're looking for there, boss. So good stuff. In the figure shown, we got angle 2 measuring 73 degrees. What's the measure of angle 1? What's the measure of angle 1? Let's find out here. So, okay. Anybody, what are some things that you know in math that come into mind? What are some vocab words that come into mind when you look at all this? What are some vocabulary words that you see? Well, the box is a sign or a symbol of a greater thing. Yeah, what? What would that be? What would that be? Come on. Give me the names of the math. Here we go. Nathan. Booyah. Right angle. Right angle, right angle. So we recognize a right angle. Okay. Let's explain everything that we see here. We got a right angle right there. Everybody, a right angle is how many degrees? Thank you, appreciate it. That's 90 degrees, okay. That's one thing we noticed. Let me get that timer out of the way for y'all. Goodbye. All right, so we see that. What's another thing that we recognize here? What's another vocab word that we learned today, or a term here? Okay, right there, complementary angles, right? Complementary angles, we see that. We have angles 1 and 2, those are complementary. Everybody, what does complementary mean again? What does complementary mean again? What does it mean? Not two angles less than 90, not right angle. A right angle is one angle. Complementary angles. Oh, you're good, you're good, you're good. Just try again here. Two angles that add up. You got to finish the statement. You can't just leave it like that. Two angles that add up to 90. Yes, 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 yes. Two angles that add up to 90. So we know for a fact that angle 1 and angle 2, complementary. And what that means, everybody, again, this is what you have to be able to regurgitate from your mind instantly, like as quickly as possible to recognize it. And so you have angle 1 and angle 2 are complementary. So that means that they add up to 90. They add up to 90 right there. So everybody, just to give you a quick little, well, I'm going to wait till after this this problem here because I want your opinion on one way that I'm going to be modifying the math boot camp. And I think you're going to like it. So angle 1 and 2 are complementary. They add up to 90. So everybody, how do we find angle 1? What do we do? What can we do? Yeah, we've got to subtract. Exactly. If we do the 90 degrees minus angle 2, we can find angle 1. That's it. That's the answer right there. So that's what we'll do. 90 minus 73. Everybody, what is 90 minus 73? Do some mental math there. 90 minus 70, 20. Then minus 3, 17. Sounds good. 17 degrees, and the answer is B. Yes or no, did that make sense? Especially after doing the supplementary one. Did that make sense? Notice that we did the same exact thing. We subtracted one angle from another, but the number we used was different. You used to recognize, is this a straight line for 180 or a right angle for 90? And so here, question, you got the 1 from the 90. So yeah, because we know that 1 and 2 make up 90. So if we take 2 away, then all we got is 1 left. all we got is 1 left. So if right here, if we take 2 away, then we only have the angle 1 left, the 17. Boom. So with that, hopefully we're feeling pretty good there. Let's try another one here. So this is an example where they may not give you a diagram. You still have to be able to recognize what you're doing. But here's the cool thing. The cool thing is that if they don't give you a diagram, they have to explicitly give you clues and like a way to inference that you are dealing with whatever you're dealing with, whether it's a right angle, complementary, supplementary, whatever it is. When it's just words, they're going to be a lot more blatant with it. Yes or no? Does that make sense to everybody? If they don't give you a picture, you are gonna have to go ahead and have a little more information given to you, right? It has to be descriptive. So the question here is this: what is the measure of one of the angles? That's the question. The situation is you got 2 complementary angles that have the same measure. So everybody, let's go ahead and figure out what the basic rules of this problem are. We're looking for the measure of one of the angles. That's what we want. We want the measure of one of the angles. Sure. Now, what are the sets of facts that we know here? Complementary means both add up to 90. Thank you there. Let's go ahead and add that in. Complementary angles. So we know that the angles 1 and 2 or whatever equal 90. That's the complementary part. And then we see that we know that they say they have the same measure. Okay, everybody, when we know that 2 things are the same and they add up to whatever number, what do you do to find the numbers? What do you always do? If you know that 2 of something add up to some number, how do you go ahead and split that back apart into the 2? Yeah, divide in half, cut it in half. If you know both of them together make up the 1, then cutting it in half or dividing by 2 gives you what each one is. So that's the idea here. We're going to be saying that, look, the 2 angles, it equals 90. And if you divide by 2, you get 45. You get 45 in this case for one of the angles. Because again, them being the same right here allows you to do that. Saying that it's just 2 angles together, 2 times an angle. Yes or no, does that make sense? My reasoning for this, for labeling 2 angles, instead of saying angle 1 and angle 2. Like that's something that we really have to be okay with doing, because this right here translates to system of equations. Anybody here struggle with system of equations? Where you have 2 equations on top of each other? Anybody here struggles with that? Yeah. So being able to be okay doing that here is going to allow you to be okay, more okay doing it in there. So Krishan, this leads into systems of equations. Just want to make sure you understand that. Okay. So there we go. The answer here will be 45. 45. So that gets through our guided warm-up. For the rest of class here, we're going to be going through a lot of exercises here. Now, I want to go ahead and again take a moment to ask y'all again about this idea. So you guys know how keen I am with mental math, and I really want to go ahead and kind of just reveal this to y'all because this is a big project that we're working on. But my question that I asked myself the other day was, what if we had mental math, but for every single topic? Not just mental math calculating. What if we had mental math for proportions, mental math for solving equations, mental math for finding angles? So one of the things that I'm looking forward to building in the math bootcamp is basically a bunch of like time drill sets that you can reset and get randomized questions about like the basic sets of facts. Like, okay, the angle measure is 42. What is it? Acute, supplementary, acute, supplementary, obtuse, or right? And you got to like basically drill and kill as fast as you can off of those sets of facts. Would you guys like something like that? And also mental math with problems like this, where it just says, hey, these are complementary, angles this, find the other one, and do it in your head, 10 seconds or less, like those basics. Would you guys like that? Yeah, I'm going to do both. I plan on doing both. But like, this is going to be one of the, I always say it's like every project that I do is always the biggest project I've done. But like, this is going to be like, honestly, the most manpower heavy project I've ever done. We're going to have 5 people working on this. So just wanted to like run it by you guys. I'm just really happy to get it started. So we're going to have a couple of practice tests come out in March. Then after that, the math bootcamp updates are what we're working on, plus paragraph comprehension updates and word knowledge updates. So just letting y'all know. But with that said, everybody, let's go through the motions here one more time. We've got, again, acute angles on the far left. Acute and small, less than 90. You got a right angle, it's always standing right up. So boom, right there, 90 degrees. And then you have an obtuse angle. Obtuse just kind of sounds weird, I don't know. So just picture that as this blob right here, however you want to think of it. But again, whatever you can use, the more relations you can like kind of make between just random sets of facts or things that you'll remember with the math, like again, the easier it is to connect with it. So go ahead and make sure you do that. Make sure you always do that. Now, take your picture. I'll give you 5 seconds here. I'm going to make sure I get out of the way. So that way you can take a picture if you'd like to. 3, 2, and 1. I'll let y'all go ahead and take a picture of this one if you were not here before class started. And I'll just go ahead and actually make my face disappear there. Boom. All right, 4, 3, 2, and 1. Again, supplementary angles, 2 angles. Again, when they form or together, they're on the same line. So supplementary angles are on the same line. And one thing we haven't gone over in terms of a practice problem, the angles inside of a shape. So again, triangles, the angles inside of a triangle add up to 180. The angles inside of any quadrilateral. So again, any 4-sided shape that is concave, or convex, excuse me, will be 360. And then if they ask you more sides, you just keep adding 180 from 4 sides. We're going to go ahead and go through these questions one by one. But for this first set of questions, I'm going to give you a little more time than normal. Because on math knowledge, you're going to have about 1:15 to 1:30 per question. So what I'm going to do is I'm going to give you a little more time than that. And I want to give you, again, as much time as you need to really plan the problem out. That's really what I want you to focus on. So I'm going to start the timer right now. Right there. So again, don't worry about trying to solve the problem all at once. Just worry about trying to figure out like what's going on and what you need to do. And so once you have a plan, I want you to type in the chat box, say, hey, I got a plan. And time. I see a huge plan there. I'm going to read that out there. So, okay, since it's a triangle, we have a right angle. We have one of them being 90 and 45, and so, or excuse me, 40. And so, boom, the other one's going to have to be 50. Boom. Sounds good. So with that said, everybody, let's go ahead and kind of, I'm going to make an example out of this problem. So notice how I didn't actually tell you guys before this problem what a right angle was. Now, some of y'all may have already known what a right triangle is. Or I think I said right angle, excuse me. A lot of y'all already know what right triangles are, but there's a good, decent amount of you that don't. So just to prove a point, yes or no, do you know all the facts of a right triangle? Okay, so that's a lot more no's than yeses, actually. So let's go ahead and take these notes down because you now see this as important. So everybody, when it comes to a right triangle, everybody, how many angles does a triangle have? Exactly. So a right triangle, it still has 3 angles. One of them is a right angle. That's it. It's in the name, right triangle. So 3 angles, one of them is a right angle. And everybody, if it's a right angle, how many degrees is that? That's right, 90 degrees. So again, that's all a right triangle is. It's a triangle with a right angle in it. Right triangle, right angle inside of a triangle. Done. So the problem here gives us 40 degrees and 90 degrees. Did anybody here try to find that that third angle, what that would be? Did everybody think that that's what they had to do to find the third angle? Okay, so yeah, so a lot of y'all found that like that missing angle, right? So a lot of y'all found that missing angle to be 50 degrees. And so some of y'all are looking at the answer choices like, yo, 50 degrees ain't there. Was anybody confused at that point and gave up? Okay, I see a lot of people saying yes. Okay, cool. So y'all ain't see it yet. I can't wait for y'all to see it. So everybody, again, one of the angles in a right triangle is going to be a right angle, right? And how many degrees is that? One more time. What was that again? 90 degrees, right? Okay. Is 90 degrees one of the answers? So yeah, I mean, it's all good though. It's all good. So here's the thing. This is what I'm saying. When it comes to math knowledge, you have got to be able to use the knowledge you know. Like you have got to be ready to understand what you're looking at and basically bring about the information that you need. So this was a complete fake out question, but you can't blame me for faking you out. Like this is something that you want to be prepared for. They are trying to fake people out because they want to do two things. One, they're going to write fair questions with the intent of separating those who know what they're doing and those who don't. And then from those who know what they're doing, so you know that to find the missing third angle, you subtract and you do your thing and you set it to 90 or whatever. But from those that know what they're doing, they want to test to see who can figure it out the fastest. And in this situation, it would have just taken a quick second. Right angle, what's one of the angles? I mean, is 90 one of the answers? Oh, great. And if not, then let's go ahead and do what we got to do because I know how to do it already. But you look for that killer, that quick one-hit kill. Is it there? Oh, it's not. Okay, cool. Then I know what I got to do. Take the time. Do it. Yeah, absolutely. I will draw the triangle. But there it is. So does that make sense, everybody? Again, it's not about knowing how to, it's not just about knowing what you're looking at, knowing what to do. Then it evolves into doing it the fastest way possible. Does everybody see that there? And that comes with paying attention. Again, paying attention and knowing what you're looking at. So here we go. Let's go ahead and find that other angle if you wanted to solve for it. Let's go ahead and find out what it was. So if you're looking at this, you have a right triangle. This is what a right triangle looks like, everybody. That typically works. 2 seconds right there. There we go. So this is a right triangle. And we got ourselves that right angle right there. So that's 90 degrees. And then we see right here, it contains a 40-degree angle. Right triangle contains it. Nice and easy. So I'll go ahead and say right here, that's 40 degrees. And so what are the facts of the situation? It's all good. So let's look at the facts of the situation. Everybody, a triangle, the angles inside of it have to add up to what? Come on, what do we know about that? The angles inside of a triangle have to add up to 180. And sorry, I'm going to put my phone on Do Not Disturb. There. So yeah, it's going to add up to 180. All three of these, it equals 180 degrees. So everybody, how can we find the missing angle right here? Knowing that one of the angles is 90, the other one's 40, you're just missing the last one. What can we do to figure out what that angle is? What can we do? What can we do? Krishan, exactly. Subtract. Subtract them. Exactly, Krishan, my man, exactly. So if we just take away the 90, everybody, what's 180 minus 90? Right, that'll be 90. And then if I take away the 40 degrees, what do I have done? That's going to be 50 or 60. Which one is it going to be, my party people? 50, 50, 50, 50. Yeah. So 50 would be what's left. Right there. That's 50. And so my assumption is that a lot of y'all, when y'all found the 50, you were so proud knowing that you had to do it. And you look at the answer choices and you're like, I know coach ain't do me like that, right? That's probably what a lot of y'all were thinking. Like, yo, I know I did this right. I really trusted you, coach. Why would you do this now? So here's the thing. What could be one of the other angles? It was right there the whole time. Pay attention. So with that said, let's try another one out here. I got y'all. So if I got you, give me a yes. Just curious. If I got you with it, give me a no if you did not. Muhammad, I got you too. That's my goal every class, to stump Muhammad. So cool. Right on. All right. So now we learn from it, right? Now we learn from it. You might want to pay attention to maybe 1 or 2 more questions like that in today's class. I don't know. So here we go. Let's try another one here. So a right triangle contains 35-degree angle. Which of the following could be a measure of one of the other angles? So I'll give you again that minute and 30-ish seconds here. Boom. let's go here. And before we begin, I think Carrie Ann, you've been waiting for a minute. So Carrie Ann, what is your question before we move on? I hope you're having a good day today so far.
Hi, Coach. Hi, everybody. Good night. No, I was going to answer it.
Oh, what's up? Go ahead.
Okay, you want me to do it now?
Oh, yeah, please.
Okay,
So first start off with read the question. What are we looking for? Yeah.
Okay, so we're looking for the measurement of the other angle. I double checked the answer choices because you caught us on the last one. So I see that 90 wasn't there. So I knew that wasn't one of the selection. So what I did was I start off with it being the right angle, which also has measures, what is it? 180, but it has like a right angle right there that measures 90. I hope I'm saying it right.
Oh yeah, I'm writing notes down for you.
Okay, so what I did was I subtract the right angle, which is 90 from the 180, and it gave me 90 again. And then I subtract the 35 from the 90, and it gave me 55.
Gotcha. So with that said, Carrie, I just want to add one fine detail here, and
Okay.
in terms of just like visualizing it here. But you said it's perfectly right. So just for the purpose of like relaying it to everybody, one thing was the visualization right here. So everybody, just a quick fact check here. Triangle, all the angles in a triangle. What we wrote down for the fact is it adds up to what number again? 180. Yeah, it's going to be 180. The angles on the triangle add up to 180. So what you need to do, if you have, think about it like this. If you have two of those angles, so right here and this one right here, if you wanted to find this one right here, is it not fair to say that if you took out this angle and this angle from here, what's left is the remaining angle, that third angle? Yes or no? Is that fair to say? If you know what all three of them together make 180, if you take away the two that you know, you'll have the one that's left. You will have the one that's left. So that's what you're going to do here. So Carrie Ann, you explained it perfectly. I just couldn't draw fast enough to visualize that for everybody. So that's on me. But excellently done. Appreciate you. And so with that said, let's go to work. So Carrie Ann had us, hey, subtract that 90, subtract that 35. So 180 minus 90 is 90. Take away that 35. Don't trip over it. Do some mental math. Subtract the 30 from 90, that's 60. Subtract 5 from 60, that's 55. And there you go. 55 degrees. There's your answer. Nice there. It's B. Boom. So with that said, any questions here before we move on? Because again, right angles were something that we didn't prepare for. And I just wanted to prove a point here in terms of just the importance of recognizing what you're looking at. So I highlighted everything that was important here. Right triangle. The moment you hear right triangle, you're thinking, yo, right here. You have a triangle with a right angle in there. 35-degree angle fits in there somehow. And if you're looking for the third angle, we got to know how to manipulate it. Are we trying to add everything up to get to 180? Or are we trying to take some things away from 180 to find a missing piece? So are we adding all the pieces to get to 180? Or are we taking pieces away to find the missing one? That's always what you're doing in math. You're either working forward or working backwards. You're either building it or destroying it. Building it or reverse engineering it. That's always what math is. Are you going forward or backwards? That's all it'll ever be. So yes or no, did that make any sense at all? Math is always about understanding if you're moving forward or backward, and you have to understand every topic in that way. What's the forward? What's the backward? Cool. So let's go ahead. Can you go back up to the 180 because I'm lost right here? Yeah, remember, the angles in a triangle add up to 180. The angles in the triangle add up to 180 here. So let's try this one. Let's take a look at a different situation. Again, everybody, look at the picture. Look at the words. Do they give you any clues as to what math ideas you're looking at? Let's go. Again, let's check it out. So let's see. Freddie, you trying to explain the problem? Is that what you're trying to do here?
Yes, I am. Good evening.
All right, let's try it out. Ready? Welcome in.
All right, awesome. So we know that angle 2 is 38 degrees. That whole line is 180. So what I did, 180 minus 38 degrees, which got me 142, which was for angle 1.
All right, so why is it 180 degrees? Can you give me that vocab word?
So it's 180 degrees because it's a straight line.
Well, yes, a straight line adds to 180, but angle 1 is not a straight line, and angle 2 is not a straight line.
Correct.
Together they make a straight line. What's that
Angle
called?
1 and angle 2 equals 180.
Right, and what's the vocabulary terminology for that? Angle 1 and 2 are what?
Jeez.
There's C and there's S.
It's oh my gosh, concession.
It's all good. Look at the chat box here. Look at the chat box.
Supplementary. Oh no.
Oh yeah. Yep. It could be supplementary right there.
There we go. Yeah.
So let me just ask you this, Freddie. Freddie, is it fair to say that, and you guys answer this question too, but is it fair to say that the diagram helped you immediately recognize that the angles were supposed to add up to 180? Yes or no? Is that fair to say?
Yes.
Okay. Now, is it also fair to say that it might have been a little tougher if they didn't give you the diagram and they just told you that the angles were supplementary?
Yes. Yeah. Well, yeah. For me, it would. I'm usually, I like a picture of it.
Right. And you, like most others, are visual learners. You, right, like a lot of people here, are visual learners. So here's the thing, guys. Like this is a crutch right here. The diagram is a crutch. And that means, like, if they give it to you, great, it's awesome. But you got to be ready to complete problems where they don't give you this. You have to be able to recognize it visually and understand it, in language. You have to be able to pick it apart there too. Because if not, then you just risk losing points where you don't need to on the ASVAB. All you have to do is know the difference between complementary and supplementary. Everybody, which one of them adds up to 90 degrees? Type it in the chat box, go. Adding up to 90 degrees, complementary. That's correct. Now, which one of the ones are the ones that add up to 170 degrees? None. The answer is none. I said 170 degrees, not 180. So we have to pay attention there to that as well. Not just reacting to what you think you heard, but like really pay attention. I said 170, could have said it a little clearer, but point being, you got to make sure you know your facts in and out. All right. So, okay, the answer there would have been, if it's one angle, that's 170, that's obtuse for sure. So I'm not doing it to be mean. I mean, I can't see you guys cry in front of me, so I can't really be happy. But at the same time, I'm just helping you guys grow. So with that said, let's go ahead and check this one out here. We just have to take 180 and take away 38. Because that'll give us the remaining, that'll give us that angle 1 that's there. So again, to kind of do the math there, just take away the 30, you get 150. Take away the 8, 142. Boom. Right there. Cool. So I'm going to check out some of these. School made this topic complicated for some reason. Well, no, the thing is, schools just didn't have enough time to teach everything. We should probably be teaching half of what we're teaching and take double the amount of time to truly understand it. That way we can actually learn what we should be learning in 6th grade and then build on it in 7th grade, as opposed to doing all the same lessons in 6th, 7th, 8th, and 9th grade. I don't really get it. But we should be taking our time and teaching everything the right way to have a fundamental understanding of it, logical understanding of it, as opposed to memorizing a language. Like, try to memorize Spanish. See what happens after a month. You forget everything. So that's just my opinion. I only have a master's degree. I don't have a doctorate, but I've done so much research on this that it's just, I don't know, baffling. So next here, everybody, 30-second question. Let's go ahead and try this one out here. Right there, 42nd question. I saw that Shamaria had a question. Let me go ahead and make sure I answered that. I got you. So then after this question, I'll have her ask if you want to use the mic, Shamaria. For sure will. Looking at our final 15 seconds, Shamaria, if you want to ask what you might be confused about, I got you, okay? I'll do my best to answer your question. So go ahead and just let me know. All right, so if you haven't had the chance to put your answer in yet, go ahead and put your answer in. Time is up. Let's go ahead and get to it. So Shamaria, you're asking, you were wondering how they got the 180 in the last problem. Yeah, for sure. I got you. So Shamaria, there's two things you always want to recognize here, or the difference between two things. So Shamaria, remember this. This right here. So over here. Oh, that's right. That's not going to go because I need to make straight lines. So we have that right here. That is a right angle. Okay. This is 90 degrees. A straight line, 180. A straight line right there, just like that. That is 180 degrees. So as long as you know those two sets of facts, you'll be able to recognize that two angles that form a straight line, no matter how they form it, doesn't matter how they form it, it'll always add up to 180 degrees, always. So I just wanted to kind of show that and play that off there. Keep that, next to you. That way you can refer to it as you need it. So here, a right angle is an angle that measures how many degrees? Okay, so a right angle, remember, if it stands right up, it's a right angle. And remember, that is the in-between. That is the in-between that we have been looking at. Because again, it could be more than 90, it could be less than 90, but a right angle is right at 90. So that is A, exactly 90. Exactly 90. That is A. So I think the majority of us got A there. Cool. I think everybody got A. Oh, almost all of us. Man, that's fair. It's still fair. As long as we know now, moving forward, we're good. Next up, here we go. If the measure of angle 1 is 90 degrees, what is the measure of angle 4? Go ahead and give you guys that time that you need, starting now. Final 2, 1, and time. Answers in, everybody. Answers in. What is your plan? What is your plan? What was it? What was it? What was it? Let's go ahead and turn it over to Jordan here. Let's see what you got, man.
All right. So basically I looked at not the answer, but like what it shows. So I looked at so basically they're all the same in the centromemory. And once I found that out, I just basically did 180 subtract 90, and it gave me the same answer. So all four of them all together is 90.
They're all 90, exactly, because if angle number 1 is 90, everybody, 90 plus what is 180 degrees? Because again, a straight line would be 180 degrees. So 90 plus 90. Okay, and everybody, if it's a 90-degree angle, then should it have a box? Yeah, if it's 90 degrees, it should have a box, yeah. So then if this right here is 90 degrees, well, 3 is on the straight line with it. So what does angle 3 have to be? Yeah, that's on a straight line too. If that's 90, and this is on a straight line, then this has to be 92. And so I hope you guys see the ridiculousness here. All the angles have to be 90 degrees. If you have 4 angles that are like that are intersecting, and one of them is 90, they're all 90. They're all 90. They have to be 90. Because on one side, you have to be 180, so you got to be 90. On this side, we got to make 180, so you got to be 90 as well. And so it kind of just goes all the way around, nice and easy. So great explanation, Jordan. That's why B is the answer. So again, the straight lines, so like this, have to add up to 180. So even if this is 90 degrees, if you take the whole 180 minus the 90, you'll get 90, making this right there 90 degrees. So yes or no, everybody, does that make sense for you? Want to make sure we're good there. Again, I'm really looking forward to us being completely, like I mean completely okay and unbothered by the terminology that we see today. Like that's really the next step. I'm not gonna judge you if you can't finish it in a minute and a half, 2 minutes. That's not the problem today. The problem is, can you just recognize the terminology? That's the first step. So let's go into this next one here. I'll give you guys another minute and 48 starting right now. Okay, quick question. Is it fair to say that you asked that question sincerely because you're starting to understand this so well that you're like, okay, I see what we're doing. This is definitely super straightforward. Is that fair to say? Yeah, right. So what I want to pay attention to then is, okay, I'm glad that that's the case. And that's the point at which everybody here needs to work toward, where you are like, you're so good at this particular topic or concept that you're bored. Like you know how to recognize it. You know, you can do it left and right. That's the idea. So everybody looking at this diagram, we understand that the angles here, 1 and 2 are what? What is the name of it? What is the name of it? Give me the name of it now. What are those two angles? Say the whole thing. They are supplementary. Supplementary. That's right. That's right. That's right. Two supplementary angles. They add up to 180. So right there, they add up to 180. Okay. So with that said, let's go ahead and draw the facts of the situation in. We see angle 1 measures 117. We want to know angle 2. So angle 1 is 117. Angle 2, we don't know. Everybody, what do we need to do to figure out what angle 2 is? What do we need to do? We need to subtract. That is correct. That's correct. Y'all shorthanding supplementary and subtract with sup and sub. You threw me off for a second, guys. So with that, yeah, go with the whole thing. So with that, add up to 180. So we'll do 180 minus 117. And that should give us the answer again, because if we just cross that out right there, we will have what we need. So that's the idea. So here, so what we'll do is we'll subtract 100. So that's going to be 110. Then subtract, or excuse me, that's going to be 80, excuse me. So 180 minus 117. Subtract 100, you have 80. Subtract the 10, you got 70. Subtract the 7, you got 63. So with mental math, you can break it apart one at a time. Give yourself a 63, and you're good. Boom. So what if you're given 3 angles in the diagram? So great question. Great question in the comments here. So if Iteo asks, hey, if we're given 3 angles in the diagram, everybody, is it still true that if you had 3 angles here, like let's go ahead and say we just threw in this right over here, and we got a 3 right there. So let's say we drew it like that. Everybody, what fact of the situation does not change at all? Joy, that's right. 180 degrees. All 3 of those angles lie on a straight line. So you got to recognize that you got a straight line here. You got all 3 angles lined up on a straight line. They all add up to 180. So if you take it, do you see that, boss? Cool. Right on. I'm glad we can see it. So that's the cool thing about it. Like, so that was a great question. And I love that we're able to recognize that, yo, we have to look at the facts of the situation, not just the numbers. So good stuff. So with that, let's go ahead. I believe Marquette asked about that. So Marquette, I shall deliver. A little challenge question here. Go ahead and try this one out. I'll give you 2 minutes here. Marquette, I don't know how you knew that this challenge one was coming up next, but everybody thank Marquette for this one. Here, gang. So first things first, everybody. What is the question asking us to figure out? What are we looking for here? Right, we're looking for angle C. That's what we're looking for. We're looking for angle C. And everybody, angle C, is that on a line? Is that on a right angle? Is that on the shape? Like, what are we dealing with? Angle C is inside of what shape? Right, inside of a triangle. Exactly, it's inside of a triangle. So our job right now is to kind of set the stage here, kind of set the visuals. That way you can see what's going on. So let's go ahead and start with a visual here. Because again, notice how this problem didn't give us a visual. Didn't give us a visual. So let's go ahead here. Okay, there's my triangle. I'm going to assume it looks something like this. All right, so with that, I'll go ahead and mark this off over here as angle C. I'll mark this as angle A. And I'll mark this as angle B. All right, so let's go ahead and kind of write some basic facts about this situation, everybody. Everybody, we're looking for angle C. They give us clues about angle A and angle B, but they didn't really quite do too much. But everybody, given the situation, given the information we have, what facts can we draw out of this that could potentially be useful? What facts can we draw from this that could potentially be useful? Right, 180, the measures in a triangle, the angles, they add up to 180. Yes or no, everybody? Is that a correct statement? All three angles, A, B, and C, the three angles in the triangle, add up to 180. Yes or no, is that true? So angle A, angle B, and angle C, they all got to add up to 180. They all have to add up. All right, cool. So let's go ahead and see if we can kind of bring about some more facts about the situation and see if we can use them to our advantage. Let's try it out here. So everybody, one thing I noticed here was that it says angle A is double angle B. I think we all saw that kind of there, right? So everybody, is it fair, just reading that again, like let's read it again here. Angle A is double angle B. So is it fair to say that we could replace angle A? We could say that it's double angle B. So like we could say that it's 2B. Everybody, would that be fair? Could we say that A is the same thing as saying 2B? Is that fair to say? We're just kind of, again, just using the facts of the situation, saying exactly what the problem said it is. We just turned it into math. That's all we did. So, don't point the finger at me. That's all I'm saying. A is double angle B. Okay, let's take a look here. It says angle C is triple angle A. So angle C is triple angle A. So if that's the case, everybody, would it then be fair of me if it says that C is triple angle A? Everybody, if you're doing triple of something, what number is that associated with? Because double is 2, triple is what? Triple is 3. So check this out over here. Check this out over here. C is triple angle A. So I can say 3A. Is that fair to say? Replace C with 3A. I could do that if I wanted to. So this is where things get a little tricky. This is what makes this a challenge question, everybody. The questions that I've asked up to this point, these are fair questions. But now this is where you get into needing to know this topic called systems of equations. So here's what I'm saying. Everybody, when you're looking at an equation, you notice that the equations that you're solving always have one variable. Always. It's either all x's or all y's. But when you have an x and a y in the same equation, y'all ever notice that y'all can't get an answer for that? Like you can't actually get one number for that. You can't get the variable by itself. Like if you have two variables, to get one by itself, the other one's on the other side. So it's like, what? So that's the thing. If you want to solve an equation, you need to have the same variables. You need to have one variable for one equation. An equation can only solve one variable. And so that's the thing here. We got how many variables? We got 1, 2, and 3. This ain't going to go well. If we can find a way to turn this into the same letter, I don't care which one, because we can use it to find the rest. But if we just change this to the same letter, we'll have an easier time solving this. Yes or no? Do you see where I'm coming from? Do you see where I'm coming from when I say that? Like, if you want to solve an equation that has 3 variables, you need to actually have 3 equations. But here you got 3 and 1. We got to change it to 1. So how we're going to do that is this. Everybody, earlier we made the statement here. A is the same thing as 2B. So what I'm going to do, everybody, is this. We said it earlier. A is the same thing as 2B. Everybody, is it okay if I do that? If I replace A with 2B, are y'all okay with that? Right on. Right on, right on. Let's keep that B right there. And then we got plus C right here. So everybody, what did I say earlier again? I said if I have to solve one equation, I need how many variables in that equation? You need how many of the same variable? We need one. We need one. Which variable do we need to change to B? Which one do we need to change? We need to get rid of that C. We got to get rid of that C somehow because we have, we have 2B over there. We got B over here. Now we have a C. Let's try to find a way to turn that C into a B. Let's try to find a way. So here's what we can do, everybody. What we can do right here is this. Everybody, is it true that A is the same thing as 2B? Is that true? Is that still true? Sounds good. Watch this. A, I'm going to replace with 2B. So I got 3 on the outside. We now have that 2B replacing the A. Boom. So everybody, when you have a number outside of a parentheses and a number inside of the parentheses, what does that mean you're going to do? What does distribute mean? We're going to do what again? Yeah, we're going to multiply. So this right here turns into, everybody, 3 times 2 is 6. So that right there is 6B. Perfect. And so we know that C is the same as 6B. Everybody, by logic, everything we did was correct. Do you see how we went from C being the same as 6B? This is some advanced mathematics. That's why I'm taking this as slow as I can. But I want you to watch this recording again if you were confused. Like this specific part of the recording, watch it again. Take a note down. We're about an hour and 40, I want to say an hour and 28 minutes into the recording. Just trying to time it out for y'all. It's about an hour and 28 into the recording itself. So write that down. Watch this again if this is confusing you. But what we can confidently say is that C, using that logic that we just used, is the same as 6B. So I'll write that right there. So I know this might be confusing some folks, I know, but we have to be able to learn this eventually. So that's why I want to clip this as a recording to show y'all, some of this later on so you can kind of appreciate where we're coming from. Because if we're solving an equation, everybody, aren't we able to combine like terms here? Aren't we able to do that now? 2B plus B plus 6B. Everybody, if we add all these together, what does that turn into? What does all that turn into again? If you have 2 of something, you add 1 of something, and you add 6 more of that something, total, that's going to be about, 9. Because you have 2 here, plus 1 is 3, plus 6, that's going to give you 9. So it's going to be 9B equals 180. And everybody, fill in the blank here. Solving equations is the art of what? Solving equations is the art of what? Marie, I love that you pay attention here. Yep. Solving equations is the art of working backwards. Carrie Ann, appreciate you. Nathan, appreciate you. Marquette, appreciate you. Yes. Solving equations is the art of working backwards. So right now what we notice is that, 9 and B, that's 9 times B. That's the same thing as saying 9 times B. So if we want to get rid of the 9 to get the B by itself, you got to do the opposite. Because you were multiplying 9 and B together. To get rid of the 9, do the opposite and divide by 9. And so that right there, boom. And what's going to happen here on the left side is that that's going to cancel out, leaving you with the opportunity to get B by itself, which if you take 180 divided by 9, 18 divided by 9 is 2. You got a 0 at the end, so that's 20. So again, 180 divided by 9 is 20. And there's your answer right there. B is 20 degrees. Is that the answer, everybody? No? Come on, guys. It's not the answer. Everybody, you got to keep your eye on the prize. What was the question? What are we looking for? We want C. We want C. 20 was there. So if you did some of the work, you would have been kind of, you would have been overtaken and you may have picked A20. Did anybody here pick A20 for that reason? You thought you found B and you were like, oh, okay, I'm done. Appreciate the honesty there. Now from here, let's go ahead and find C. Oh, what do we notice here, everybody? Oh yeah, we noticed that again. We talked about this earlier. Right here, C is the same thing as 6B. 6 times B. We have that right there in plain sight. C equals 6B. Everybody, what was B again? What was B again? Quick in the chat box, what was B again? Yup. 20, 20, 20. So we plug in that 20 that we had earlier. And again, that's going to be multiplication. Everybody, what's 6 times 20? 6 times 20 is going to give us 120. And that's going to be the answer. So again, I know that was a lot. And we're going to go back to some more basic questions, some more fundamental questions. But I really wanted to go over that one because one, it's a challenge question and y'all deserve to see how hard it can get. But two, really to get you paying attention to the little things. Because when you're just doing those simple problems, it's so easy to just memorize and gloss over. But when it comes time to actually recognize those fundamental facts in bigger problems and use them all together, you know, that's really the level you want to get to, knowing that these topics are all kind of related. Exactly. This is algebra blended in with geometry here. This is algebra blended in with geometry. And this happens all the time in the real world. Always. And so the way that we got 120, I'm going to review this just briefly in one more way to show you how angle A, B, and C are supposed to add up to 180 here. So first things first, we were looking for angle C. So really quickly, we got angle C by knowing that it was in a triangle. A triangle has 3 angles. So we had A, B, and C. So that's the one we're trying to find. Now, what we know automatically, before we even look at the information that they give us, we know that the triangle is going to add up to 180. A, B, and C, it's a triangle. It's supposed to add up to 180. We already knew that right up there. Here's where the problem came up, guys. The problem came when we were looking at these clues here. Angle A is double angle B. Okay, so what does that mean? Angle C is triple angle A. Okay, what does that mean? What does that help us with? Because we're looking at this equation and we notice that we're in a jam here. If I only have one equation, I can't find out what any of these things are. I need to eliminate them or find out what they are to plug them in. And that's what this is about. This was all about plugging things in to turn A into just talking about it in terms of C. Think about it like kind of converting or translating currencies. So converting from one currency to another, that's kind of what we're doing. It's kind of like saying, hey, these 3 things add up to 180. But this one is in the Canadian sense, this one's the American dollar, and this one is the British pound. All 3 of these needs to add up to $180. Well, don't you have to translate or convert the British pound and the Canadian dollar? Yeah, you have to convert them first and then do your thing. Another way you could have done this was using the answer choices. So watch this, everybody. With the answer choices, if you pick 120 for C, look at this. If angle C is triple angle A, if C is 120, okay, what's the opposite of tripling? Divide by 3. Everybody, what does that make angle A? If we divide by 3, we get what? 40. Okay, so using this logic, A would be 40. And then if we see here, it says angle A is double angle B. So if 40 is double B, what does B have to be? For 40 to be double B. Opposite way, 20. Think about it. If you have 40 and that's double over there, if I say, I got $40, I got twice the amount of money you have, that means you have 20, right? So B was double A, so that means, or excuse me, A was double B, so that means that B is 20. Everybody, do these 3 add up to 180? Is this an actual triangle? Is that an actual triangle? Yeah, because they add up to 180 degrees. They add up to 180 degrees. And that's why this confirms that it's the correct answer. Because when you plug the answer choice back into the situation, you see that you have a triangle. The 3 angles need to add up to 180. Try that with any other answer. It will not work. Okay, it will not work. And I want to go ahead and basically, I'm going to give away another free shirt right now. If you can do this, and it's going to take me a couple of days because I got my flight at like 5 a.m. tomorrow, but if you can send me a picture on your phone of you working this out and showing me how, if you tried to use, if you plugged in A, plugged in B, and plugged in C, if you show me the work and show that it doesn't work the right way, but if you show me that none of A, B, and C work and D does, first person to do that gets another ASVAB shirt. Okay. So, but I won't take any submissions until after 8 p.m. So that doesn't mean start doing it now. That does not mean start doing it now. I won't take any submissions until after 8 p.m. The angles in any quadrilateral add up to 360 degrees. Right there. 360. Booyah. Exactly. If you're getting harder questions, if you get a question like this, everybody, so take another picture if you need to. But if you get a question like this on the ASVAB, you should feel pretty good about yourself. Like, this is a tough question, and you only get this unless you are on a streak of correct answers. So, like, these are the ones you want to get because it shows that you're high up there. It's all good. We'll get better. You know, we talked about your situation. We'll get better. We'll get better. Next, here we go. So again, the angles in a quadrilateral add up to, we just saw the answer here, 360 degrees. I'll give you all 2 minutes to try this one out, and then I'll take over. And this might be the last problem of the class. And again, so if you want to learn if you won the shirt, stay to the end. And also, we will be talking about the program and how you can easily sign up after class as well. But it's going to be cut a little short because I do have to pack for a very early flight. So let's go ahead and check this out here, my party people. Which of the following is the degree measure of that missing angle? So what is this missing angle right there? David, are you raising your hand because you want to answer the question? You're going to try to, oh, I don't see you on the camera there, but are you raising your hand because you want to try to answer it? I'll go ahead. Okay, cool. Go ahead.
All right, mic check, 1, 2. Can you hear me, Coach?
Yes, sir. How we doing, man?
We doing good. We doing good. Now, I believe, if I'm saying this right, I believe the whole shape of itself is 360, around 360, right?
Yeah.
So what we got to do is just basic subtraction. We got to subtract 360 from the 123. And then, you know, we're going to go ahead and do that, subtract from the 123 again. And we're going to get that number. Now, the final number we're going to have to subtract it from is the 47. And due to my mental calculations, Coach, we should end up with 49.
You should end up with 49. All right, sounds good. Who agrees? Hey, right on. Let's go and do the math there. Yeah, with mental math, if I'm looking
Appreciate
at that,
the hand
yes,
raise.
it is.
I'll be
It
here
all
next
adds
week.
up to 360. Good job, David. So 360 degrees is the total. Booyah. And then from there, if we take away the 180, or excuse me, the 132, if we take away the other 132, and then if we take away the 47, you'll get yourself what's left, which is again going to be what's missing. So there's 2 ways you can really do this. One way, you can just go ahead and add all the angles up first and then subtract it from 360. Or you can go ahead and subtract them one at a time. Either way, it's up to you. Either way, personally, I think that you should just start right away with mental math subtraction. That's just personally for me. There's less steps. There's reasonably less steps. And you'll be able to just go ahead and say, okay, 360, 260, 160, 100, 60, 53, 51, 49. So that's how I look at it with mental math. Again, I'll just run my pencil across the numbers and just do the subtraction in my head continuously. And I kind of plan out what I want to do. So yes or no, was anybody able to follow along with the mental math that I just did? When I went from 360, I just subtracted 100, 260, 160, 100, 60, 53, 51, 49. Yeah, that's how I perform the mental math there. You don't need to actually do the borrowing and do all that stuff. And I have a bunch of mental math videos in the program. I'll talk about that in a bit. But if you didn't get it, it's all good. That's a more so advanced way of doing mental math. But once you know that advanced way, you get to do these problems like cake. Anybody on the iPhone mental math app notice that when you try to do the 3-digit subtraction, you kind of freeze up a little bit? If you even tried the 3-digit subtraction, because I know it's a little intimidating. Yeah, what you want to end up doing, the key there is still split and glue. You're just splitting it into the hundreds, tens, and ones. Instead of just the tens and the ones, it's the hundreds, the tens, and the ones. That's really what it is. So there it is right there. The answer will be 49 after you put in all that work. Booyah. There we have it. Boom. So with that said, it is 7:56. So we got two things going on here. So one, we're going to pick a shirt winner. Oh, what's up, David? You got a question? And Jordan, right before we finish.
Right now, sorry to disturb the raffle, but I did have a question. So you're saying the more questions you get right on the math knowledge or any particular topic on ASVAB, the harder it will become?
Yeah, it's trying to keep you within your range of difficulty. So if you get harder questions, that means that you likely got the not the direct last one, but maybe you got one of the last ones correct. They're not gonna make it obvious that they're changing the difficulty up on you, because then they would make it obvious that they're basically giving you they're making it obvious that you got the last one right or wrong. So it's like a pool of questions that you've taken already. So like the first 5 you've done, then it might kick you into another harder set of questions or a less difficult one. It's not always one by one. It could be a pool of questions that they judge it off of. Because, for example, just because you got this problem on perimeter wrong, does not mean that you don't know how to do solving equations. So that's where I'm coming from with that. So I just want to make sure that's very clear.
Okay, so it's like a 50-50, basically.
No, it basically depends on the pool of questions that you got correct or incorrect. So overall, if you got 3 questions and 2 of them was right, 1 was wrong, then it might kick you up to a harder set.
Okay.
Which is a good thing because your score goes up. That's a good thing.